I hope concept 1 is clear to you everyone. Now concept number 2 is distance never be 0 but displacement may or may not be 0. We will understand this concept by taking an example. A particle is moving in a circle of radius r. What would be the distance and displacement after complete revolution? Now we have to find the distance. What distance is? It is the actual path covered by a body, right? When a body covers a complete path, this is what? This is the circumference of the circle. You know the formula of circumference of the circle? That is simply 2 pi r, where r is the radius of the circle. So the distance for this particle is 2 pi r, right? Now we have to find the displacement. After completing one revolution, the initial point is A, and after completing one revolution, final point is what? That is B. Both are same. So displacement is final position minus initial position. Final position कौन सी है? A. Initial position कौन सी है? A. तो A minus A is 0. From this example, what we will conclude that if we take a round trip and reach back at the starting point, then we have traveled some distance. We have traveled some distance, that is 2 pi r, but here the displacement is 0. The next, we'll differentiate between distance and displacement, or you can say that there is a comparison of distance and displacement. The very first is, what distance is? Is the actual length of the path covered by a moving body. What displacement is? It is the shortest distance between the initial position and final position. Direction is not associated with the distance, right? It means direction is not needed. In displacement, direction is associated with the distance. Next is, distance is what's a scalar quantity. Displacement is a vector quantity. Distance is always positive and displacement may be positive or negative. We have explained this in a previous example. Distance, the value of distance can never be 0 for a moving body, but it can be 0 in case of displacement, right? When the initial and the final positions are same.